Our lesson for today will be looking at chemistry 1502. The topic for today is alkyne reaction. We'll be looking at hydration, lesson 105. Let us start. This reaction is the same as acid catalyzed hydration. So we need an acid, but we hydrate, we don't dehydrate, we hydrate. It simply means that we put in water. So you should know that the reagent that we'll be using, or let me say the acids, or the catalyst, let us just say the catalyst that we'll be using mercury sulfate, but the main aim is to use this mercury, but it comes in a form of mercury sulfate and H2SO4. This will go hand in hand with water, since we said we hydrate. This reaction is also known as mercuric ion catalyzed hydration, and this reaction basically it's an alkyne undergoing acid catalyzed addition of water across the triple bond in the presence of mercuric ion as a catalyst. And then this is the reagent that we normally use, and you should know that it follows Markovnikov's orientation. And the product, as expected, will be an alcohol, but that will be the stage whereby it is not the final product, because most of the time it will yield a vinyl alcohol, which is an enol, and an enol is not a stable product, so it will undergo another process called tautomerization to form another carbonyl functional group, which is a ketone. So the general equation, let's say we have a terminal alkyne reacting with water in the presence of sulfuric acid and mercury sulfate. Between the two carbons, we can see that this is the Markovnikov carbon. So we are going to have a stage whereby we yield a vinyl alcohol or an enol. Remember, in enol, it's OH, which is the hydroxy group is bonded to the carbon that has a double bond. Since we said it will follow the Markovnikov orientation, it simply means that since this one is the most substituted, our OH will come here. Remember that it consists of OH and hydrogen. So this part will go to the Markovnikov carbon, then the other part will go to the other carbon, which is involved in the double bond. Then you can see that this is an enol, since this hydroxy group is bonded to the carbon that is bonded to the double bond. So this is an enol. Automatically, this will tautomerize. It will actually tautomerize. This word sometimes can be difficult to pronounce. So it will tautomerize to ketone. What happens during tautomerization? What happens is that there is a movement of a bond and hydrogen. This hydrogen will come here, then this bond will come here to make it more stable, and then we yield a ketone. So you can see that we have an alkyne which and then tautomerize to form a ketone. Let us look at our first example. We have butane, but1-ine. It's a terminal alkyne. We react this with water in the presence of our catalyst, and then this will form an enol. This is our Markovnikov carbon. So you're going to have hydrogen here and hydrogen here. Then we have this part and our oxygen here. It undergoes tautomerization. Bear with me, this term I cannot get used to pronouncing it, so please bear with me. Well, I've decided that actually this should be a double bond. I've decided that I will not try to pronounce this word again, but I hope on my next examples you will see from here to here it's that particular step. So this is our ketone. The name will be but2. It's butan 2O. Let us go ahead and do this example. Plus H2O. We need our catalyst. So this is the Markovnikov. It will undergo the process. This should be, actually I've just copied the very same thing. Remember, we need a ketone. Then we can just, this should be our answer. Let us do the next one. Let's say we have CH3, CH2, C triple bond C, CH2, and CH3. We react this with water in the presence of HgSO4 and H2SO4. So you can see this is an internal alkyne and it is symmetrical. So we do not have a Markovnikov carbon, so we can just add. If you add it here, it simply means that we are going to start from here. If you add it here, we are going to start from here. So the two are the same. So we can just go ahead and we have CH3. Let me actually do this CH2, CH3. Then I'll put hydrogen here. And then this carbon, it's this one. And then I put CH 2CH3, and then we have our OH here. It's an enol. It undergoes the process to form a ketone. So we are going to have CH2 CH3, we have H here, then we have double bond here, there's actually something wrong here. Here we have this part which is CH2 CH3, and then we have hydrogen here. Suppose you have an internal alkyne but it is not symmetrical. React this with water, the presence of our catalysts. So you can see that this is a secondary carbon, this is also a secondary carbon. So what do? We are going to have a mixture of two products. So looking at, we are going to start by adding here and add here. Looking at the enol, we are going to have our first OH will be here with the double bond, plus, remember that hydrogen it is there, but since we're using a skeletal structure, we don't have to draw it. Then OH will be here. These are enols. They undergo the process tautomerization. I'll get used to the word. We are going to have a mixture of products. Oxygen plus oxygen. I hope you can see. Well, this reaction is simple. Just know the mechanism, but this is just a summarized mechanism. That's it for this lesson video. This is Fahula SJ. Thank you very much.